All right, guys, the final phase, close phase. This is where closing callbacks are scheduled. You know, it's interesting that this is its own phase, but that's how Node did it, and that's how libuv did it. They wanted a dedicated phase for any closing event, right? The most important ones here are really when you close a socket or close connections. You know, uh, the main reason for having a close dedicated close phase is that this is where callbacks of close events are getting scheduled. So if you schedule a close somewhere here in the poll phase, the close event will be thrown at the end, right? The close callback will be thrown at the end, scheduled here. And it, of course, it won't only be, this is one of those callbacks that is marked as ready versus that has a state. Like, is this callback ready to be executed or not, right? And you might say, why? The reason is because closing something takes time. Closing something is an IO. Right? If I close a file, you're destroying the file descriptor, right? If I close a connection, that's even more expensive. There is a four-way handshake that happens in the TCP. Like you do fin, ACK, and then another fin, or sometimes in worst cases, a reset will be sent. But that takes time. There's an exchange that need to happen to actually fully, cleanly close the connection. So that takes time, right? And close events are there for cleanup purposes. So they are also low priority. It's like, hey, at the end of the day, just let's alleviate the poll phase for more important stuff and throw the close phase at the end if you want to close the connection. Very similar to pending callbacks, but pending callbacks are delayed even further because they are errors, right? So we want to delay it even further just in case we want to pick up uh, an error and retry. Close, if you actually forcibly close something, you're technically done with it and you just want to clean it up. So yeah, so we're going to wait for the poll and then fire the close event. And then when we come to that state, we're going to execute the callback only if the callback is marked as ready, of course, right? And here's an example. And there's not much to say in this phase, to be honest, just a straightforward phase. We might do it. Let's do it. We're gonna do it in this to show you what is going on behind the scenes as always, because this is something worth it. All right. So what did I write here? Destroy the socket after 5 seconds. The destroy is an IO, as I talked about, which is scheduled in the poll phase, right? Dude, guys, can we appreciate this? Can we just just forget about the code? Can we just appreciate that? And I don't know about you, but I love when something is vague and blurry and all of a sudden it just makes sense. I love, this is my mission in life. My mission in life to de-blurry law, blurry, bra, deep, I don't know if this is a word, de-blur everything. That's my mission in life. Because we spew a lot of BS as a human, you know, mostly because of our egos. Like we try to show off that we know, so we throw these big words left and right. But my mission in life is to take this BS and just de-blur it and make it clear and visible. And I absolutely love this stuff. This is my job. I think this is my mission. Take something that is blurry and make it clear. And it feels good. And if you want anything as an advice in life, follow that feeling good. Not because your mind told you to, so because it's a direct feeling, right? You see there are two types of feeling. I know we're going into philosophy, but what do you expect? This is Hussein Nasr course. Do you expect to learn actually technology? No, this is a philosophy course. So there are two types of feelings, you guys. There is a feeling that comes from a thought, from a mind. You think about something and then generates a feeling. I see an animal that is about to hit me. The brain thinks, oh, it's gonna eat you, so it generates fear. Someone tells you that you have to do a presentation on stage. That generates a thought. Oh, what if I stumble my words? What if I say something wrong? What if this? What if this? What if this? Oh, you're not good enough, or something. The mind will just spew all sorts of beautiful, weird, odd thoughts. It's just nonsense. And then these thoughts generates feelings. So this is the first type of feelings. Yeah, you want to ignore these type of feelings as much as possible. And then there is another type of feelings that generates from the heart. There's just boom feeling. There's no thought that comes before it. Right? You see a pretty woman or a beautiful man, and then immediately there is something, right? That's a feeling. That's your mind didn't tell you anything. Now that can generate other thoughts. Of course, this core feeling can generate a thought that, oh, you're not pretty enough to talk to her, which generates fear. The other type of fear. You see how I did this as software engineering? But yeah, you have a core feeling, that's truth, right? Generates a thought, that's false, right? And then that generates another feeling, that's also, you can ignore that, right? The original one is the important one. Another thing is like you see a beautiful scenery and then it does something to you, right? Or you feel some anxiety sometimes about certain situations without knowing what's going on. Your mind doesn't understand it. That's the true feeling of the detectives are also have this, right? So I feel there's something here, right? It's just, anyway, let's go back. It's too much philosophy for today. But yeah, yes, destroy is an event. This is an IO. IO takes time, right? Nothing is free. Now, what I want you to do is go back to every single Node.js code you have. This is your exercise. Every single Node.js code you ever wrote in your life. Go and look at every line and just try to understand what it does. In the beginning, you might understand 30%, then 40, then 50, then eventually you're going to understand maybe 90, right? And this is a difficult task to do because your mind will say, you don't have to do this. It's just code runs. Why care? Absolutely, that's you're within your right to say, hey, if the code runs, don't touch it. Nobody's saying touch it. Just understand it. Just fun. It's fun. No one is rushing you to do anything. Right? You just watch this course, and there's nothing to do after this. I'm not going to give you action items to do. Right? This is just you just enjoy. Right? Any thought that comes to your mind is just false. Remember that. Destroy. We're going to destroy it after 5 seconds. Which is funny enough. This function is a callback that is set on the timer phase. I love this stuff, you guys. I love it. 6:30 and 6 in the morning. That's the only time I can record stuff. And otherwise, once the boy wakes up, I cannot do anything. Unless you guys enjoy maybe yelling in the background of the course. That's a different story. Okay, so we have this to destroy it, and we have a close event. We're listening on the close event. When the close happen, call this function, right? Events are interesting, guys. I don't think we talked about it, right? So there is, if you think about it, this is also an event, right? The timeout is also an event. Like when this happens, do this. If this happen, if the 5,000 millisecond elapses, execute this callback. This means if that clause finished, call this. And you can summarize this if you want as this callback is there in the clause phase. It's just there is a state next to it. Ready, not ready. 1, 0. That's it. Here, same thing. There is one callback and there is a ready, not ready. Here, connect. Right? Ready, not ready. Is this callback ready or not ready? Who sets it ready? Whoever agree on the event, on when, on the definition of the event. And boy, you can have disagreement of what clause mean, right? That's why you have sometimes before clause, sometimes after clause, sometimes on clause. Sometimes there is ambiguity on connect. What does connect mean? Does it mean like I about to connect? Does it mean a connection successful? What if the connection failed? That's another event, right? So there's million things that could go wrong, and that's where you come in and demand perhaps, hey, Node.js, I think we're going to benefit from a new event here when this particular thing happened, right? And they're going to fight in the issue and say, no, you don't really need it. And that's all about what life is about. Yes, this will run in the close phase after everything in the iteration is done. Okay? So simple thing, we connect and we close. And this will trigger after 5 seconds. How about we go and do the close phase execute after the check phase? Right? Because that's the diagram. Let's do an exercise, guys. Let's do an exercise. I'm gonna go to my Ubuntu machine for this one because we're gonna need. You know what we're gonna need, guys? I'm gonna do an S-trace. And unfortunately, alas, as the Japanese say, zannen desu ne. Zannen, we cannot do S-trace on Mac. See? And this the closest thing to S-trace is FS usage, which sucks. I don't like it one bit. It doesn't have details, dude. It doesn't have enough details. So let me SSH to my machine this net. 168.7.179. Uh-oh. Was it 197? I have no idea where's my... Uh-oh, did my boy unplug that machine? Because it's behind the sofa. He might have unplugged it. Now it's there. Good. Good, he didn't unplug it. Boom. What do we have? We're what? Not streams. We're doing close 707. Guys, do you appreciate these numbers? Because I don't know, I find it easy to kind of go through them. All right, so requiring net, because that's where the sockets are, right? Print client success. We're connecting to this guy, and then we, after 5 seconds, we're destroying the client connection, and then on close, we're gonna print connection closed. Right? I think we might have some parameters on connection close. I don't remember. You can do fancy things like when we actually initiate the close versus when the connection close, how long did it take? You can do magic, you know, timing like that. So yeah, let's do that. Yeah, how do you do that? S-trace -f -t. F is for forks, follow the forks. -t give me timeouts, give me timers, timestamp, sorry. And then output is out.text. You can throw the output somewhere else if you want, right? And keep all these outputs. Actually, that's a pretty good exercise for you guys to just save all the outputs and just push it to your repo. And then we're gonna write node. We have this, and 1, 2, 3, 4, 5. Boom. Sweet. Now we go from out.text. Look at all this stuff. Isn't that beautiful? I don't know about you, but I love this stuff, man. I don't understand every single line here. Like I know there's some map, but you can see what Node did here, right? Like there's so much stuff, but I'm only interested in the things that I know happen, right? Like let's find my socket. We created a socket. This is a client-side socket, you guys, right? But if it's technically it's the same thing, same object. We're creating a socket, and I want a stream. That means TCP because TCP is stream. It's a non-blocking socket, and I want to connect to this IP address, which is example.com. And sometimes this trace will say, hey, operation is in progress. Say, hey, when we did this, we're trying to connect. We're not listening. We're connecting because it's a client side. And what else we need to interested in? What did we get? When we connect, when we created a socket, immediately we got a file descriptor. It's a local thing. We because that's how connections work. On the client side, you got that 20, and we have an epoll object. The epoll itself is number 13. That's the data structure, and they're adding a bunch of 14 and 16. I don't know what this is, to be honest, right? But this is what I'm interested in. I didn't notice doing all sorts of things, sorts of epolling on other things, but we're interested in the 20. 20 is my connection. We're listening to the connection, and the epoll. Look at this. You see this? It says, hey, because we created a connection. When you create a connection, what do you want to do first to it? You don't want to read because there's nothing to read. You want to technically write, right? So that's why it says, hey, this connection is already ready for write. I want to check if it's ready for writing or not, right? And it's interesting because you really need to listen later for the read. But dude, this is so cool. But look at that. So this is, I think this is some sort of an inefficiency in Node, right? What happens is like they're calling epoll on the 20 on my connection, and they say, hey, tell me if it's ready to be written to. And then later they're doing epoll says, yes, it is ready. And when it's ready to be written to, that's when you get the successful event in connect. And then only then they try to add the epoll in, right? And with this is when they get an error. So it's like, what are you trying to add? It's already there, right? You cannot add another. The file descriptor is already there. You already have that in the poll, so you cannot add. So they get an error, and they turn around and do a modify. So my question is, why didn't you just do one add with both epoll and epoll out and epoll in? So that's something that could be improved, right? Yeah. Of course, this all depends on the Node version. So I'm using version 22 in this particular case, right? But things can change, of course. And if you ever did S-trace and you saw IO ring, I suggest you move to a version that doesn't have IO ring, because that just complicates way so much stuff to understand, right? Because you really, what we're interested in here is understanding. IO ring does things very differently, and honestly, it's in its own course, right? So we can stick to things that we need to understand, and then slowly up the difficulty, right? So if you've ever seen IO ring in your S-trace, just roll back to another version. That's in my opinion, at least. Right? If you want to understand what's going on here. Yeah, so we're doing a modification to add that stuff, and eventually that's what we're interested in. What are we doing here? We did a wait, and then look at this interesting thing, right? These two things. This, do you remember where this executes? Equal CTL, the control? Yes, in the prepare stage. So in the prepare stage, we received a close event. Someone executed this close event from the node. And what happened is, the first thing that we hit is the prepare. So in the prepare, we removed the epoll, remove the connection, which is 20, from the epoll data structure file descriptor, and says, hey, let's prepare this, let's clean it up, nothing to do here. Then we move to the poll phase, and what did we do? We actually initiated the close. Say, hey, nobody's listening to anything. It's safe to close, because you don't want to close while the epoll is listening. That's just weird, right? So you need to remove it. And then once you close it, you wait. You await that. It says, all right, now tell me, are there anything to be done here? And then, only then, you receive that, yes, there's nothing here, all clean, we received the close successfully. That's when we actually go ahead and execute the event. And then we're removing a bunch of other stuff that I don't know. I still don't know what 17 is, to be honest. Then, like, it's probably somewhere here, but I couldn't find 17, right? So yeah, that's one of the mysteries. S-trace will be interesting. Sometimes it doesn't capture everything. But, what else? Anything interesting here? By the way, this is the thread ID, like where this thing happened, right? You can clearly see when did this thing happen as well. So if you do like a file read, chances that the read is gonna happen on a different thread is higher. Right? All right, guys, that's all for the close event, close phase. We're done with this theory stuff, if you will, talking about the phases and the event loop and understanding. I think by now you have maybe like 60% understanding of this event loop, and I think by now you have this 60% to 70% understanding of the event loop. You know this as an outline. Okay? Now it's time to kind of dive deeper into each of these internals, right? We're not yet to go to the next, ready to go to the next section yet, but I think that's the event loop in its most simple, basic thing. Right? Some of the phases you'll never have to worry about. Some of them are just keep them in the back of your head, right? It says, hey, this is how things work. But now you might need to come back to that diagram that we drew, right? And all right, we're not done with the event loop. There is two more things, which is the process next step, very critical one. But yeah, this is the pure. I forgot that I'm not sharing my screen, but this is it. This is the event loop, you guys. Initial phase, timers, pending callback, idle preparing the structures for I/O. Right? Whether you're adding things to the epoll or removing things, that's all the same thing. Then you actually poll, then you check, they sit immediate, and then close callbacks at the end, and then boom, boom, boom. You keep doing it over and over again. Some callbacks, some phases will have 0 queues, right? And the callbacks will have 0 queues, so just move on, and then some of them will have things to execute. And then we do this as long as there's stuff to do. We execute it. Once we're done, this event loop is deinitialized and destroyed. Let's go to the next lecture.